Have you ever looked up at the night sky and admired the stars? If you're anything like me, you'll do it whenever you can. Have you ever wondered about those stars? Where did they come from? Where are they going? Well, in my last video, I discussed the formation of the solar system. I definitely recommend checking that out because that explains in a bit more detail about how stars form. But in this video, I'm going to discuss their formation and their lifespan and their ultimate end. We're going to be talking about the life cycle of stars, or stellar evolution. So stars always start off as nebulae, massive clouds of gas and dust in space. And these will collapse under their own self-gravity, getting hotter and denser until they form an object called a protostar. It will continue to collapse until the pressure inside the protostar gets high enough to start nuclear fusion. This is where a nucleus of an atom forms a bigger nucleus by colliding with another nucleus. We're literally fusing two atomic nuclei together. And this releases a lot of energy in the form of radiation. And it's at this point that the object can be considered a star, when nuclear fusion is going on in the core. Now, the first type of nuclear fusion to happen is between hydrogen nuclei. It's the lightest element. And while hydrogen fusion is happening in the core, we say that the star is on the main sequence. Main sequence is just the name that we give to stars which are undergoing hydrogen fusion in the core. And this is a very long period of a star's life, up to 10 billion years. Our sun is currently a main sequence star. Now, while a star is on the main sequence, there's still that inwards pull of gravity, but the star doesn't get any smaller because that's balanced by the outwards radiation pressure and gas pressure inside the star. So the star is stable while it's on the main sequence. There's a tongue twister. Stars are stable on the main sequence. Whew. Now, after the main sequence, stars will change in different ways depending on their mass. In this video, I'm going to consider two simple diverging paths that a star could take, the two that are on the physics GCSE, just to keep things simple. One is for stars that are about the same size as the sun, and one for stars that are a lot more massive than the sun. So let's start off with sun-sized stars. There's so much alliteration in this video. When the hydrogen inside the stars is used up, it will expand, cool down, and get red. If it's about the same size as the sun, it turns into something called a red giant. Now, nuclear fusion is still going on inside red giants, but it's not hydrogen fusion anymore. So red giants are different from main sequence stars. Now, eventually, the fusion will stop happening. It will run out of fuel altogether. The elements get heavier and heavier and heavier until you can't do nuclear fusion on that anymore whilst releasing energy. It's a little bit complicated. We get up to iron and then fusion can no longer happen inside a star. And then at that point, there's no more outwards radiation pressure because there's no more fusion happening in the core. There's no radiation pressure pushing back against gravity anymore. So what will happen is the gravity will cause the red giant to collapse and get very, very small. And it turns into something called a white dwarf. And white dwarfs only continue to glow because they've got some leftover energy from the old nuclear fusion reactions. There's no fusion happening inside a white dwarf star, but it still glows with some leftover energy. But it gets cooler and dimmer over a very long period of time, and eventually it will turn into something called a black dwarf. And it will stay as a black dwarf potentially for the rest of time. So what about stars that are much bigger than the sun, stars that have a lot more mass than the sun? Well, they go through a similar evolution at first. They expand, turn red and cool down as well, but they get much bigger. So we call those red supergiants. And again, they continue nuclear fusion in the cores up to iron until they run out of those lighter elements. But at that point, it will shrink down again. No more radiation pressure, but it shrinks down very rapidly. You get some weird things happening in the core with shock waves, and it causes a huge explosion where all of the gas and dust of the star is thrown out, loads of energy released, and we call that a supernova, and they look fantastic. And that supernova will then create a new nebula from which other stars might someday be born. Left in the middle of a supernova will be a teeny tiny, very, very, very dense star called a neutron star. Or if the star was really massive in the first place, you'll be left with a black hole. Well, there you have it, a basic introduction to stellar evolution. I hope you enjoyed it. Hope you found it interesting. Think about that the next time you're gazing at the night sky.